Hi, this is Prasanna from Wave Academia. In this video, we are going to see about how to simulate bidirectional DC-DC converter using Matlab. Okay, let us go to Matlab. So for the development of bidirectional DC-DC converter, I need a switches and I need a filter capacitor and I need a load and the important component is battery. Okay, first I will select the components. I'm going to select a switch as a MOSFET. I need two switches. So in this switch, it's having the terminal like D, S and G are there. But one more terminal M is there. That M port I don't want actually. If you want to measure the voltage across the MOSFET and current through the MOSFET, you can use this port M. Otherwise, you can disable this one. Okay. So now it's having the source, drain and gate is available. I can say that this is P side MOSFET, or I can say that this is N side MOSFET. So in this series also branch, I'm going to use only a combination of RL and then so in this combination I'm going to use the combination of RC. So now the simple DC-DC converter is completed, and one thing I have to include the battery. Okay, so I'm going to take a battery. So many batteries are there. I'm going to pick the battery from specialized power systems. Okay, so this is my battery source. I'm flipping it. Okay, fine. So this is nothing but the battery. If you double click the battery, you can select any type of battery: lead acid, lithium ion, nickel cadmium, nickel metal hydride, whatever you want. As of now, we are going to use lithium ion because lithium ion is the most widely used batteries in any electric vehicles. Even if you take nowadays laptops, mobile phones, we are using only lithium ion. Okay, values and all I will let you know later. So if you want to know, if you want to take the parameter out, you can use the M port of battery. For that, I need a bus selector. So once you connect the bus selector with the M port and double click on the bus selector, okay. So what are all the elements available in the battery which you can take as parameter output? You can see these elements. The bus is SOC is nothing but state of charge and current voltage. So before that you have to delete this one and then pick SOC, select it, select current, select voltage, and then click apply. Automatically you can able to see that the bus terminal is having three output terminals. Okay, if you want to see the output, you can use scope. So inside that scope I'm going to change the number of ports. Requirement will be 3. Okay, so once you connect it, automatically it will show you first connect. First line is nothing but state of charge, second one is current, and third one is voltage. Now the simple DC-DC boost converter is over. I want to generate the gate pulse with the help of pulse generator. Okay, so I'm going to use go to tag. I can say that the pulse generator output is directly go to P side of switch. Similarly, if you want to take N side, okay, and one more switch, but the inversion of that P side is nothing but N side. I'm going to take a not gate. The inversion of P side is nothing but N side. So now you have to name the tag accordingly. So this one is, I can say it is P underscore side, and make the tag visibility as global. Apply it. Similarly, this tag N underscore side. Make the tag visibility as global. It's a good practice. So now you can take the corresponding from tag from the P side as well as corresponding from tag from the N side. Connect it here. Okay. Now an important component called power guy is required, which will act as my solver configuration. Now I will tell you what are all the things I have to give as an input. So this, since it's a bidirectional converter, there will be a flow of current, there will be a flow of power supply from DC voltage source to battery as well as battery to DC voltage source. It will keeps on going. Now I'm going to give the input. Let me take this input voltage is 48 volts. Okay, and then this inductor and resistor, actually here the purpose of the resistor combined with inductor is it will act as a ESR, equivalent series resistance, in DC-DC converters. Actually this resistor is ESR. Here I'm going to use, actually normally the ESR value will be very low. Okay, I'm going to take zero point 0.1 ohm as the ESR value, equivalent series resistance value, and then I'm going to take 1 millihenry is the inductance value. Let it be as it is. And similarly here also, if you take the filter, there will be a series and there will be a resistor in series with the filter. This is also here it is a ESR, equivalent series resistance. The value of, actually here also the resistor value will be very low, so here I'm going to take 0.001 ohms, and then I'm going to take 1000 microfarad as the value. Okay. Now I'm going to battery. I'm going to take the nominal voltage. You can change your values accordingly. Okay. So as of now, I'm going to take my nominal voltage is 24 volts and rated capacity of current is 10. Okay. 24 volts, 10 Ah battery. So you can start with initial stages 50%. Suppose if you are starting from initial stage, you cannot able to understand whether the battery is charging or not, and moreover you cannot able to understand whether the battery is discharging or not. So if you start from 50, then you can easily visualize the output whether the battery is charging or discharging. Okay, so please, whenever you are using battery in this kind of simulation purposes, please start with 50 percentage of initial state of charge. Then you can be able to easily able to understand what's happening inside the battery. I'm going to change the battery response time is 1 e power minus 4. I'm applying it, and then I'm going to change the pulse. Actually, here, as of now, I'm giving the period is 1 e power minus 4, which directly indicates the switching frequency of this bidirectional DC converter. Okay, so we all know that there is a relationship F is equal to 1 divided by T. This time period is nothing but 1 e power minus 4. From this, you can easily calculate the switching frequency of this converter. Okay, so which will indirectly represents how fast you are making your switch on and off. It's nothing but the switching frequency. So now what I'm doing is I'm starting the system with 75 percentage of duty value. My duty ratio is 75. Okay, duty value is 75. So I'm starting with 75. So in the meantime, while the program is running, I'll change my pulse width 75, actually less than 50, greater than 50. So two conditions that will be there. So let us see what will happen if you give less than 50 percentage. What is going to be happen if you give greater than 50 percentage of duty value? Let us see, because I'm going to change the pulse width value while during running. So if you want to change the output, please specify that stop time is INF. Okay, now if you start the system, and in the meantime go to scope and go to view, change the layout. It will be very helpful to you. Fine. Now if you look at this, now the pulse generator, in pulse generator the pulse width is 75 percentage. I'm executing the program. Check out the scope. So now the battery is in charging mode. So this decreasing slope, sorry, this increasing slope indicates that the battery is in charging mode. So now what I'm doing, actually now the program is still running. I can able to change the values. I'm going to pulse generator. I'm changing the duty value from 75 to, say it is 35. I'm applying it, clicking OK. Now I'm going to scope. If you look at this, suddenly there is a change in the slope. Now it's going on decreasing slope. Decreasing slope means that the battery is in discharging mode. Battery is in discharging mode. Again, if you increase the pulse generator, say it is 65, pulse with duty value from 35 to 65, what's going to happen? Open the scope. See, look at this again. Now the battery is started charging. So in this bidirectional case, what we can came to know is If your duty value is greater than 50 percentage, the battery is getting charged. If the duty value is less than 50 percentage, say it is 40, the battery is discharging. Okay, so this circuit will be very helpful if you employ you can employ this circuit in regenerative braking of electric vehicle. So it's one of the application, I can say that, where you can efficiently use this bidirectional DC-DC converter circuit is in regenerative braking mode of electric vehicle concepts. Okay, so whenever the driver applied the acceleration, the battery is getting batteries battery is going to be discharged. There will be a flow of power supply from battery to machine. So whenever the driver applied the brake, at the time there will be a flow of power supply from machine to battery. So whenever the driver applied the brake, at the time the machine will be working in generating mode. Okay, so at the time this circuit will be very helpful to transfer the energy from both sides. If you look at the output, and you can conclude this. So this increasing slope represents that the battery is in charging mode, whereas this reducing slope will give you some output like that the battery is in discharging mode. So this is for if you keep your duty value greater than 50 percentage, then the battery is working in charging mode. When the duty value is lesser than 50 percentage, then the battery is working in discharging mode. So these are the corresponding current and voltage value of batteries. Okay, so this will be the significance from the graph. Hope this circuit will be very helpful for you to simulate bidirectional DC-DC converter. Thank you for watching the video. Kindly subscribe the channel. Thank you very much.